There is one little warning light that drives more people crazy than almost any other, and that's the TPMS light. That's the tire pressure monitoring system. It pops up on your dash and instantly you're wondering, is it a low tire or is there something else actually broken? Most people think that a light just means add some air and you're going to be good, but sometimes it doesn't go away. You top off the tires, reset the system, and the light still comes back on. And that's when the guessing game really starts. Here's the truth. That little symbol isn't just about pressure, it's about communication. Each wheel on your car has a tiny wireless sensor inside that talks to your car's computer. When even one of those sensors stops responding, the whole system goes silent. And if 3 of them stop working, like in this Saturn Vue I've got in the shop today, you're flying blind. Now, a lot of people think fixing it is as easy as buying new sensors online and going to the tire shop and having them reset it. But that's where the myth starts, because not all sensors are created equal. Not all frequencies are the same, and just replacing them doesn't always make the light go out. So in this video, I'm going to show you what's really happening behind the scenes with the TPMS light. We'll scan the system, find out which sensors are dead, test the signals, and I'll explain exactly how the computer reads and sometimes loses communication with your tires. By the end, you'll know how to diagnose the system like a pro and avoid wasting money on parts you might not even need. This isn't a guess and check repair. This is real-world automotive diagnostics. Let's dig in, and I'll show you what's really going on behind that little yellow light. Before I get into the problem that we're having with this particular car, the Saturn Vue, I want to just talk a minute about tire pressure monitoring systems and the sensors, kind of how they work, a brief overview so you can get an understanding of what it is we're looking for when we diagnose the problem. So there are a couple of different types of systems that work for tire pressure monitoring. And one of them is the direct system and one is the indirect system. A direct system is going to have a tire pressure monitor inside the wheel. It'll usually have something similar to this. It's got a little transmitter in there that's sending us a radio frequency signal out. Now this type of system usually will have a valve stem with a aluminum core on it, aluminum stem on here. Some of them do have the rubber stems, kind of like this car does as well, so it's not always a great indicator of what type of system you're working on, but sometimes if you see those aluminum stem on there, it generally means you do have a tire pressure monitor inside the wheel. And that's with the direct systems. They'll be using one of 2 frequencies. They'll be using 315 megahertz or 433 megahertz in order for the system to communicate with the receiver, which is inside the computer on the car. Sometimes they're in the wheel wells. Sometimes they're using the key fobs receiver. And there's several different systems out there, and they all work a little bit differently. But they all need to communicate by sending a signal from this tire pressure monitor to the receiver inside the computer somewhere. That's how those will work. And then there are indirect systems. The indirect systems will generally use an anti-lock brake speed sensor. It's just measuring the rotation speed of the wheel and comparing it to the other wheels on the car. Generally, they should all be rotating at the same speed. If you have one that's got a low pressure, its speed will change in correlation to the other wheels on the car. And that's an indirect system, no sensors inside the tires. Now that being said, they both do similar things, although usually these are more accurate. They allow you to identify exactly the tire pressure and also allow you to see battery life on each individual sensor inside the wheel. So some pros and cons to both. I don't want to get too much into those, but I just wanted you to know there are 2 different types of system. You need to be aware of what you have in there. So you may have a car with an indirect system and then you put some new wheels on it and you think maybe we forgot to change the sensors or something, but it doesn't have them. It just needs to be relearned. Okay, so the relearn procedure is part of what we're going to go through here today on this car. Every vehicle has its own relearn process. Some of them are extremely difficult and some of them are really easy to do. Just depends on the manufacturer and the model that you're working on. Although there are different systems depending on the car and the model, most of them are going to give you a similar indication on the dashboard. You're either going to have a malfunction light that is on, steady, a malfunction light that's flashing, maybe a malfunction light that's flashing and then goes steady, or you might have some other driver information center system separate from the light that's giving you some indication you've got a problem as well. So it just depends on your car. You can always check your owner's manual to see what those warnings mean and what needs to be done about it. Generally speaking, we see two types of things going on here. Either the light is on steady right after you start the car. That usually just means you've got a tire that's low. It's letting you know, hey, look over here, I've got a tire that's not reading the proper pressure. Maybe you should go out and check the tire pressures. The second scenario is usually a flashing light. And almost always a flashing light is telling you there's a problem with the system somewhere. It doesn't necessarily mean that you have a bad sensor. It does mean, though, there's a problem with the system. Now, that problem could just be a bad sensor. It could be a bad receiver. It could be a communication problem somewhere. It could be a host of things. But either way, you're going to have a flashing light first to tell you there's a problem with the system that's going to require further diagnosis. Now that you've got a little overview of what's going on with this tire pressure monitoring system, let's talk about this Saturn we're working on. This one has got a tire pressure monitor light, a malfunction light that's on steady. So it's generally telling you it's got a problem with the tire pressure being low. And we didn't have any indication of a flashing light on here. It actually took quite a while for this light to come on. So we're going to go through the diagnostic steps here and show you what's happening with it and how we test it and where we're going to start with it. I did want to mention in here that these sensors have a battery inside. Each one has a battery, and a battery life is usually somewhere between 7 and 10 years. So when we're looking at a car like this that's a 2008 model, we don't know when these sensors have ever been changed, but it's a good indication to us that, hey, we're probably going to be looking for a problem with these sensors. Even if they're still reading right now, they're probably going to give us a problem anyway. This model year 2008 Saturn Vue that we're working on today came into us with a very specific problem. And what I told you earlier about the light flashing versus the light on steady, it doesn't always hold true because this particular vehicle didn't have a flashing light. So it wasn't indicating exactly that it had a malfunction within the system, but the light is illuminated. Now, the first step with any diagnosis is to check all of your tire pressures. It is extremely possible and extremely likely in most scenarios that you just have a low tire. Now, you may have picked up a nail or a screw somewhere. Maybe you have a valve stem that's leaking air, the Schrader valve's leaking. Any of those things are possibilities. And obviously the first step is you want to go ahead and check all your tire pressures, note the pressures, and see if any of them are low. And just a reminder here too, the spare tire oftentimes has a tire pressure monitor in it as well. So if you've got 5 tires on the car, you want to check the pressure in all 5 tires regardless of the size of it. So make sure you're checking all of them, don't miss that one. We see a lot of times where we've got a tire pressure monitoring system warning light on, and it's actually the spare tire, not any of the regular tires. So a good one to look at. And you should be checking your spare tire pressure from time to time anyway. In the event that you need it, if it's got no air in it, it's useless to you. So another thing that I think we should talk about here is the ability to do this project at home. Now, tire pressure monitoring systems require a couple of tools for you to work on them. One, we need some sort of a scan tool usually, or we need something to activate or trigger the tire pressure monitor sensors themselves. We need something to go ahead and send a signal to it and say, hey, communicate with me so we can test and see if it's giving that feedback. We'll be using a tool like this today. I'm going to show you another tool here we can use as well. Some of them are less expensive, some are more expensive. If this is the type of work you want to do in your own car, you're going to require that tool. Now, that being said, the tool is not the only thing that we're going to need. We're going to need probably some new sensors at some point. These sensors come in some different styles in here. Other than the frequency that we talked about, there's 2 different frequencies they communicate on. You need to make sure you have the right frequency for your particular vehicle, and that usually requires buying something application specific for your vehicle. So you would tell them, I have a 2008 Saturn Vue, give them the information, and they'll try to pull the correct sensor for you with the correct frequency on it. Inside that new sensor, there will be an identification registration code in there, and that code is really important. We have to program that code into the onboard computer system of the car. If the code is not in there, it won't be able to communicate with it. So the second part of needing a tool like this one is to be able to register the new sensor identification numbers in addition to being able to trigger them. So this tool is all in one, and some of the other ones are as well. There are some standalone tools that will allow you to trigger the sensors but won't allow you to re-register the IDs in there. It requires a separate tool. So be careful if you guys are shopping for tools out there. I'll put a couple of links up in our Amazon store so you can see some tools that are affordable that should get the job done for you. If you're buying a sensor that has the correct application for your year, make, and model with the correct frequency built into it, it will have its own registration ID code built into it as well. That's not the only option for you though. We have a tool here made by Autel that allows us to actually take a generic sensor, and we can either clone the original ID number, or we can input a new registration ID number and then enter that into the vehicle's onboard computer. So it gives us a couple of options. We can take a sensor like this that has no registration ID number in it at all, and we can put one into it. And we're going to show you the process of that, how it works with this particular scan tool. Now, I can tell you that there are not a lot of scan tools that allow you to do that. Autel is one of the few manufacturers that actually makes their own sensors that work well with their diagnostic equipment to allow it to be programmed. So we're actually going to communicate with this sensor using this tool. It's going to send a signal to it and input an ID registration number into this sensor. It is blank right now. And one of the reasons we like to use these is because these fit just about every vehicle out there. So instead of trying to get application specific on them and trying to get one that has the right ID registration on it that we have to enter in the system, we can actually just clone whatever's in the car already. And here's one of the advantages to using this, and I'm going to use a specific reference because Chryslers are one of the cars out there, the newer Chryslers, that really give you some trouble. If you don't have gateway access, I don't want to get into that right now, but gateway is like a proprietary special access with the scan tool in order to be able to communicate with certain systems. And if you don't have gateway access at home, which you won't, you're not going to be able to enter the information, the ID registrations, into the computer. So the easiest way around that, without the gateway access, is to be able to clone the old sensor. So we're basically just going to take this new sensor, we're going to take the old registration ID number, and we're going to put it into this sensor. And what that allows us, the system, to do is just to function normally without us having to re-register those identification numbers into the car's onboard computer. So I know it gets a little bit confusing, but I hope you follow along with that, because there's a big difference between cloning and creating a new ID registration number. And that's where an example where we would want to probably clone the system to save some work and some effort, especially if you don't have that gateway access required by some of the manufacturers. Now, before I get off of this subject of special tools you need, in the event that you've got a tire pressure monitor that needs to be replaced, they're going to be inside the tire. So that's going to require you to remove the wheel from the vehicle, air it down, break the bead, and put a new sensor in it. And if you don't have tire equipment, it usually is fairly tricky to break the bead on these automotive tires. So it might be something best left to a tire shop. Now that we got that out of the way, let's show you what the process looks like and figuring out what's wrong with this car. After you've finished the first step of checking and adjusting all the tire pressures, including the spare, the next step for you here is going to be to try to trigger all the sensors on here. So what I want to do now is I'm going to use this tool, and it gives you a process of where to start. So we're going to start on the left front wheel, and we're going to try to trigger the sensor. Now what we'll do is we'll hold this tool close to the valve stem, and then we'll press the trigger button. We want to see it's going to activate the sensor that's inside behind this valve stem, and then it's going to send us back the information from that sensor. Now, as you can see, we've already done this here, but I'm showing you that this sensor is not functioning. It's not triggering. It's not sending any information back. It's telling us we're having a problem with the sensor on here. So we'll let this go for a minute or so. It'll eventually time out and tell us that it cannot communicate. And once it does that, once we've done that a couple of times, we'll pretty much have identified that this sensor is not working. So if you can see here on the tool, it's telling us the left front wheel has failed. Okay, and then we're going to work our way around the car from the left front to the right front. We'll go ahead and select the right front wheel, and then we're going to trigger this one. Again, we want to be somewhere near the valve stem. Press trigger. And you can see how quickly now that this picked up a signal from this sensor. This sensor is working fine. It's given us the information we need out of it. We're going to move on to the next wheel at the right rear, passenger side rear. Same process near the valve stem. And we're going to press trigger. So now the scan tool is sending a signal out at the 315 megahertz, trying to communicate with this sensor. And you can see how long it's taking right now. It's giving us an indication there's a problem with that communication. Okay, so we had a failure at the left front and a failure at the right rear. We've got one left to do. We're going to move on. All right, now that we've tried to activate all 4 sensors, or possibly 5 depending on your vehicle, the next step in the process here is to check for diagnostic fault codes in the system. So what we've done here is communicated with the onboard diagnostic connector underneath the dashboard, and we're trying to access the tire pressure monitoring system's module and see if there's any fault codes stored. Now this one here is showing us that it does not have any diagnostic trouble codes. It's showing up green. There's no list of indications on there. So basically this system is a fairly old one. A lot of times some of the newer cars will have fault codes stored for sensors that don't communicate. There'll be communication type codes. This one's not giving us any of that. It's gone back to the, stripped down to the basics basically, and is saying, hey, if you can't communicate with it, you've got a bad sensor. So the next step in this process here is to replace the sensors that aren't communicating, and that's what we're going to do. I want to show you the process of installing a new tire pressure monitor sensor. Like I said earlier, it requires us to break the bead down in order to replace it. The first step we need to do is to let some air out of the tire. We'll remove the core of this valve stem by taking out the Schrader valve. Once the air is out, we can break the bead. And then what we're going to try to do is we're going to try to install the sensor without dismounting the tire at all. And that should save us from having to rebalance the tire again as long as we don't move anything. So with our bead broken down, we're going to put our tire machine in place, and we're just going to try to push down around it to give us a little bit of room to work in there so we don't have to rebalance all the tires. If we can get in here a little bit, get some room, get that bolt out. And I'm getting in here with a very low profile bit and ratchet. It's a little bit tight, and we're just going to try to see if we can get this thing loose. Okay, we got a good view there. We're going to try to loosen this bolt up all the way. And like I said, it may be easier just to dismount the tire altogether. You just have to rebalance it afterwards unless you're going to mark everything. Sometimes even during your dismount process, you might knock a wheel weight over. So sometimes it's just easier just to break the bead down like this and then try to remove the sensor without disturbing the tire the rest of the way. There you have it. We've got a little Torx bolt there, and that screws up into the valve stem. I'm going to use a valve stem installing tool, and I'm going to try to pull this valve all the way through. Now sometimes they don't want to pull all the way through, and you have to cut the bottom off of them in order to get them out. It really just depends on the car. We're going to give this a little shot here and see if we can get enough pressure on it to pop it through the rest of the way. Okay. There you have it. There's a little piece stuck down here. Try to get this off without it falling in the wheel. All right. We've got our new sensor with our valve stem. I'm going to try to install these in one piece. I think I've got clearance to do that. If not, we can separate them. Put that up through the hole. And then we're going to install our tool again. It threads right on the end of the valve stem. We'll line the sensor up where we like it. Hopefully. Maybe not. I want it to sit right about there when we're done. Just pull it through. Okay. You can see the installation in there now. It's got the rubber seal. That's what's stopping it from pulling all the way through. Sensor's in place. Slowly release this pressure. We don't want to damage the sensor at all. Okay. And then we need to put some air in the tire. Important we don't put our fingers in this area here. They can get pinched in between the rim and the bead of the tire, and then you're looking at going to the emergency room. So keep your hands off to the side or keep them away completely. We want to get this aired up to the proper tire pressure on the gauge. Now we've got our old sensor removed, the new sensor is installed in place, and all we have to do is repeat the process on the remaining wheels. Now I mentioned here earlier about the lifespan of the battery being 7 to 10 years. I know we have one wheel that's working on there and 3 that aren't, but we're going to replace all 4 sensors on here. We don't want to have a problem with that right front sensor down the road a week, a month, 3 months from now because the battery failed in it. So it's getting 4 new sensors. We'll go ahead and install the rest, and we'll get back with you here when we're done. All right, now we've got all the sensors installed. We've got all the tires aired up, bead seated, and pressure set where they need to be. We're going to go ahead and put all the wheels back on the vehicle. If you're only doing a couple of wheels, it's a good idea that you go ahead and mark the wheels if you want to put them back in the same spot. All these tires look a little shabby either way, so not really a better location necessarily to put any of these, but we'll put them back on the car. They're going to get re-registered anyway. We'll let that down to the ground, and then we'll go ahead and torque all the wheels down to spec. So the next step for us, now that we've got our sensors installed, is we're just going to try to copy these sensors here. We wanted to copy the ID numbers that were already in the system. This is usually the easiest way to do it. So I'm just going to use my scan tool here. I'm going to try to copy them through the onboard diagnostic screen. It says, you want to program this sensor. And we're going to say, okay, right here. And then we're going to come in here and try to program this one. Okay, so we've got that one copied, and we're going to move on to the next one. So now that I've copied all of the ID registration numbers from the old sensors, I've actually copied them into the new sensors so that there's no more programming or relearning that really needs to be done. That's one of the reasons that I like to use these Autel products. It's really simple to use if you're using the clone feature, because now there's not a whole lot that's left. The system already knows what's in there. So all we really need to do now from a programming standpoint is just let the computer know what location each wheel is in, and we'll go through the Relearn procedure on it anyway. But there's not a whole lot more complicated stuff that we need to do here. Now, if you're using an OE style sensor, something you bought from the dealer, then you'll probably have to install the new registration ID number. There is a function in here that allows you to do that. You can actually key it in manually if you want to. Sometimes you can pick it up through the tool by activating the sensor. There are different ways to do it depending on your scan tool equipment and depending on the sensor as well. So just want to let you know there's a few different methods in there. I really like to use this method, it just works easier. So let's get into the relearning procedure. Now that we've got all the sensor IDs cloned and programmed back into the computer, the last step is just to road test the vehicle. So we have no diagnostic trouble codes, as you saw in there earlier anyway, otherwise we would clear those as well. We've verified that all the sensors are working. You can check all the tire pressures, all the sensors are activated now. They're all showing readings on them. They're letting you know the battery is okay. We've got temperature and pressure readings. And then the last step for us is obviously the relearn procedure we talked about. Now, because we've already done most of the steps here involved in the relearn procedure, the last step is just to road test this vehicle. We've got to get it out on the road and drive it for about 10 minutes or so and this system will finish the relearn on it. It'll locate which wheels are in which spots, and we'll be set to go with this car. Now, I wanted to mention, I think I talked about this earlier, there is also a relearn procedure without using a scan tool and going through the OBD connector. So there's a combination of using the remote keyless entry key fob, the horn on the car, putting air in the tires, listening for the horn. There's a whole process for it. And then even without the remote keyless system on there, if you happen to have the extreme budget version of this Saturn, there is a way to do it through the driver's information center, using the prompts inside the center and following some of those steps again, listening for the horn by putting air in the tires and waiting for it to beep. So I just wanted to stress there's always a relearn procedure that needs to be followed. If you miss any of the steps on there, it won't relearn properly. So you need to make sure you're following all the steps exactly. If you don't have access to those, that's not going to help you, but there's plenty of resources on the internet where you should be able to find that type of information if you're trying to do it. Again, just to reiterate, this system is not complicated to work with, but it does require some special tools. So I just wanted to give you guys a general overview of what's involved in fixing a tire pressure monitoring system. Now, there are a lot of other examples in here that we didn't get to because this car didn't have those problems. So we're talking about receiver problems, antenna problems, those types of things. Those are certainly things that can creep up and give you some issues that don't require new sensors generally, and don't require us to go through this whole procedure because there's some other problem going on within the system. And I can also tell you, for all the years of doing this, those kinds of problems are pretty rare. You know, the majority of the time we're looking at either just low tire pressures, that's the most common reason the lights come on, or we're looking at sensors that are failing. So these are the two most common things we're seeing out in the field on a day-to-day basis. So guys, thanks for following along in this video. I hope you're enjoying this type of content. We're trying to bring this content to you in a fashion that you can easily digest. We can go a lot deeper in some of these subjects if you're interested in it, but I try to bring you enough information here where you can get a general understanding of these systems, how they work, and how you can apply them in your own world. Don't forget to share, like, subscribe, and ring the bell for notifications so you know when our new content comes out. That sharing and commenting really helps our channel as well. If you got some friends you know would be interested in this type of stuff, go ahead and send it over to them. And make sure you drop us some comments as well. We want to know what you want to hear about, what stuff you'd like to learn, what you're struggling with at home, or just your general experience with any of these types of things. So go ahead and reach out to us. We read all of our comments, try to respond to all the comments as best we can, and we love to hear from you. So thanks for supporting the channel. Go ahead and check out another video for us here. We've got lots of great content coming at you. We'll see you in the next one.